Continuing on with section 6.5 here, example 4 is rewriting to graph an inequality. An interior decorator is going to remodel a kitchen. The wall above the stove and the counter is going to be redone as shown on page 396. The owners can spend $420 or less. Write a linear inequality and graph the solutions. What are 3 possible prices for the wallpaper and tile? So here we're looking for cost. They're going to spend $420 or less. So the amount of money that they spend in relationship to 420 could be equal to, they could spend $400, but they can't spend $500. So the amount of money they spend has to be less than or equal to $420. Now, the things that they're spending money on are wallpaper and tile. Okay, and we're looking for the prices. So again, to find cost, we take price times quantity, or how much. If we look on page 396 here, it shows us that the tiled area is 3 feet by 4 feet. So we have a total of 12 square feet of tile. So to find our cost for tile, I'm going to make tile be X, it doesn't matter. We take 12, because that's how much we need, that's our quantity, times our price for tile, which here is going to be X, and tile price. Plus, we do the same for wallpaper, and that's going to be my Y, and that's my wallpaper cost. And it's cost because we're looking for prices. If you look at in the picture on page 396, it tells us that 3 feet by 8 feet as far as papered area go, so we need 24 square feet of wallpaper. So that is going to be our quantity, and now we need to multiply by price, and that's going to be our variable because we're looking for prices for wallpaper and tile, so those are our variables. Those are the things that change. And that's going to be less than or equal to 420. Now, a couple different ways we could do this. It's in standard form, so we can go ahead and find our intercepts. In order to find my x-intercept, so if we just used tile and decided we didn't need to redo the paper, we'd plug 0 in for paper. And solve. Divide by 12. And x would be less than or equal to 35. Now, let's say we just wanted to do wallpaper and no tile. We'd plug 0 in for tile and solve for wallpaper. So 24y is less than or equal to 420. Divide by 24. And y is less than or equal to 1750. So the amount of the cost for wallpaper is $17.50 or less. The price for tiles is $35 or less. Okay, here we also could have solved for y, or solved for x really, but if we solve for y, we can use slope-intercept form. There isn't necessarily any reason why one variable has to be on the x-axis or on the y-axis. Here I just picked them. Neither one depends on the other. These are two independent things, tile and wallpaper. It's not like our cost, for example, would depend on how much of the other. That's not necessarily what we have here. So tile is going to go on our x. So cost for tile. And then cost for wallpaper on the side. So my wallpaper is at $17.50. If we look here, I have 12. Yeah, 12. So I'm going to go by $2.50 each line. That'll get me exactly to $17.50. So I'm going to go $2.50, $5, $7.50, $10, $12.50, 15, and 1750. And that's my y-intercept, so I put a point there. For my cost for tile, my x, I need to go to 35, and I only have 12 spots here, so I can't go by 3s. I could go by 4s, but that's not going to get me to 35, so I'm going to go by 5 so that I have an even exact amount for 35. And that's my intercept. Now we can go ahead and connect these. Because it could be exactly 420, we can connect these here with a line. And as far as our shading goes, because it's an inequality, we need to shade here. And we want to be less than x and less than y. So we're going to shade in this area right here. So anything in here would work. The question also asks for 3 possibilities. We could really use any amount of cost and tile combinations here because things do come in $1.99, in $2.73, and things like that. So we could do $35 tile and $0 wallpaper. We could do 0 tile and $17.50 wallpaper. We could do something in the middle, like 15 for tile and 10 for wallpaper. We also don't have to do right on the line, guys. We can pick $14.50 and $6.85 if we wanted. Okay, because that's part of our solution set. So it doesn't have to be exactly on our line. It's anything that we shaded, anything in this whole area here. Now, for a party, you can spend no more than $12 on nuts. Peanuts cost $2 a pound, and cashews cost $4 per pound. What are 3 possible combinations of peanuts and cashews you can buy? So we're spending no more than $12. Our spending could be $12. It could be less than. It could be 9, but it can't be 15. Okay? And the amount of money we're spending, some of it's going to be on peanuts, and some of it's going to be on cashews. So the amount of money we spend is how much we buy times price. Price times quantity. Here for peanuts, our price is 2. And for cashews, it's 4. Again, we could use intercepts to solve here if we wanted. We can also solve for y and get it in slope intercept form and go from there. Since we did intercepts on the last one, I'm going to solve for y here, just to show another way. In order to solve for y and get it in slope intercept form, I subtract my 2x. Remember, we cannot combine the 12 and the 2 because they are not like terms. One has an x, one doesn't. When I divide by 4, I do it to every piece of my equation. We do it to everything. And reduce. So negative 1/2 x plus 3. Here, I'm going to go ahead and label my axes. Peanuts was x. And cashews was y. I'm going to start at 3. And my slope is negative 1/2, so down 1 over 2. Down 1 over 2. And down 1 over 2. This is at 6. This is at 3. We can connect our dots again because it's equal to. Let me try that again. And then we will shade. And we want it to be less than So we're going to go in here. Now, for combinations here, it really depends on what kind of peanuts and cashews we're buying. If they're from like those big tubs and we're just like scooping them out, then we have a lot more freedom. But if they come in, let's say they come in pound packages, okay, then our options are a little bit more limited. We could buy none, 0, 0, and just say, hey, bring your own snacks. 1 pound of peanuts, no cashews. 2 pounds of peanuts, no cashews, and so on. We could buy 1 pound of cashew and 4 peanuts, or 3 peanuts, or 2 peanuts, or 1, or none. We could buy 2 cashews, 1 peanut, or 2 peanuts, or we could buy 3 cashews and no peanuts. And that's if they're prepackaged. If they're not prepackaged, then we could have any amount. If we scoop and we decide we want 3.8 and 1.1, okay, that would be an option. So any of those are options there. Example 5 is writing an inequality from a graph. This is going to be very similar to how we did it when we were coming up with equations for lines in slope-intercept form in chapter 5. The only difference now is we're going to have to check our shading and our lines to figure out which inequality instead of equals. So instead of having y equals mx plus b, we're going to get rid of our equal sign and put in some kind of an inequality there. If I look, I know it's going to be equals to because my line is solid. And my shading is below my line, which means less than. My y values are lower. My slope between any 2 points looks like I go up 2 over 1. Up 2 over 1. And I always like to do it twice just to make sure. So my slope, rise over run, is up 2 over 1, and I get 2x. B is where I begin, and that's at my y-intercept. Here it's 1. So again, very similar to how we did slope-intercept form equations of lines. The only difference is since it's an inequality, and we know that because of the shading, we have to make sure we put that instead of an equals. Same idea here. Feel free to pause and give this a try if you'd like. So instead of having y equals mx plus b, which is what we did before, the only difference is that instead of equals, we're going to put our inequality. Here, if we look, since it's a dotted line, it does not have an equals. And we went above. We went up from any point, we go up, which means our y values are greater. So greater than. Slope here, any 2 points, and if we pick ones that are on corners, it makes it a little bit easier. It looks like we go up 1 over 3, up 1 over 3, up 1 over 3. So it's rise over run, and I get 1 over 3 times x. My b value is where I begin. On my y-axis, it's always on this y-axis, and here it crosses at -2. So y is greater than 1/3 x minus 2. Real quick recap here for section 6.5. A linear inequality in 2 variables has an infinite number of solutions, and we show that on a graph by shading. Anything that's shaded is a solution. Solutions to a linear inequality in 2 variables can be represented on the coordinate plane as a set of all points on one side of a boundary line. Remember here it's either all or nothing. It's either everything on one side is a solution or nothing on that side is a solution. And that's all I have for section 6.5.